what we wanted to see today, which is conditional probability, or the probability of A given B. So let's start with an example. So now we want to see a real data example. We will see some data that we can find on the internet. So what will be? Of course, some card game, some MTG card game. This is a card game. We are seeing it in the expansion of Throne of Eldraine, which is the one that has the funniest trailer. And we just look at the amount of creatures. That's 124. That's all the creatures. Now, which creatures are rare? We just put here rare. Let's see, 31. You see, 31. So in the Throne of Eldraine, we have 130 something creature. And let's see now the 124 creatures. 31 are rare. And we look at the fairies. So there are only 2 fairies in this in this season, and all the fairies are rare. So we can think of the probability of being rare, given that it is a fairy. Well, if you are a fairy, you have to be rare in this season of Magic the Gathering. But what is the probability of being a fairy given the fact that you are rare? Well, there are 31 rare and there are 2 rare fairies. So the probability is 2 over 31. Just by intuition. And intuitively, that is that the probability of A given B is the number of elements that are A and B, that are both, over the numbers that are only B. So by definition, the definition is different than what we think of it intuitively. The definition of the probability of A given B is the probability of A inter B over the probability of B, which goes according to what we think of it intuitively, but is a bit different. Now we want to see when 2 variables are independent. So 2 variables are independent if the probability of an event A is the same as the probability of an event A given B. That is, A and B are independent. B doesn't change the probability of A. So being B doesn't affect of being A. So A and B are independent. And kind of counterexample, having symptoms and the event of having symptoms and the event of being sick should not be independent. If you have symptoms, the probability of being sick must be bigger than being sick just because. But we will compute this independent of variable with some data we have. So in the case of being a fairy, so let's copy again all the data we have. We have 124 creatures, 31 are rare, 2 fairies, and 2 rare fairies. So probability of being a fairy was 2 over 124, the number of fairies over the number of all creatures. Probability of being a rare fairy is 2 over 124. The probability of rare, 31, 124. And then we see if being a fairy and being rare are independent or not. And they are not independent, as you can see here. They don't give the same number. The probability of being a fairy is less than the probability of being a fairy given the fact that you are rare. So some important observation we have here is that the probability, well, we have here the definition of a probability of A given B. And with this definition, we see that these 2 things are exactly the same. Probability of B given B times the probability of A given B, and the probability of A times the probability of B given A. And now we have a second observation, which then if two elements are independent, then the probability of A inter B is equal to the probability of A times the probability of B. This is not the definition of independent variables, but they are the definition of, it is a consequence of the definition. Now we will see some examples. So an amazing example or a WOW example. So yes, we will go to a different database of World of Warcraft. Here, let's put all this in. We have the probability of being in Europe of the players of World of Warcraft is this one. The probability of being in the Horde and or being in the Alliance in Europe. So this is the probability of being in Horde given that you are in Europe, or the probability of being in the Alliance or being in Europe. And the probability of being in Europe is on the other side, and this is this one here. So with this, we can compute different probabilities, which we are going to do right here. So the probability of being in the Horde and in Europe, I mean the probability of being a European Horde. And for that, we use the formula of conditional probability. By definition, the probability of being the Horde given the fact that I'm Europe is equal to this division, but we already know what is the probability of being in the Horde given the fact that we are in Europe and the probability of being in Europe. So this probability of being an European Horde must be the multiplication of these two probabilities. Which we will not do using Python, but using the normal calculator. Because this computation is not so difficult. We just put two zeros on the other side, so we have over 100, which is the definition of percent. So there is a probability of 32.66% that you are an European Horde if you play WoW. Now, can we compute the probability of being in Europe given the fact that you are in the Horde? Well, for that we need an extra data. We use the observation 1. These two have to be equal, and we have this element, but not the other one. So we go to the web page and we find the probability of being in the Horde, which is the one that we needed. We fill all the numbers. And we get the probability. Now we can ask the question, is Horde and being the Horde and being in Europe independent? Well, we can see here the probability of being in the Horde and the probability of being in the Horde given the fact that we are in Europe. And not. They are not independent, but they are close to be dependent, which is something to be expected. And this is all. Hope to see you next time. And hope you enjoyed the video and this random fact about Magic the Gathering and WoW. Bye!